Imagine a world without light, a realm of absolute blackness, where even the faintest glimmer is swallowed whole by the depths. Here, the sun is only a memory, its rays unable to penetrate the endless miles of water above. We descend into the Mariana Trench, the deepest part of our oceans. A place so remote that few have ever dared to visit. The pressure here is unimaginable, like an elephant balanced on your thumbnail, multiplied thousands of times over. As we sink, sunlight vanishes completely, and the temperature drops to near freezing, chilling every surface to the core. Our submersible hums through the silence, a fragile bubble in a hostile world, surrounded by darkness and the unknown. At nearly 11,000 meters, our lights reveal a landscape of pale sediment, rolling hills and deep canyons carved by ancient forces. The pressure is over 1,000 times greater than at the surface, changing the very behavior of molecules and testing the limits of human engineering. For centuries we thought nothing could survive here, believing this abyss to be a barren wasteland. But as we touch down on the Challenger Deep, we see a world hidden from human eyes for all of history, untouched and mysterious. The darkness is absolute, the environment alien, as if we have landed on another planet entirely. The crushing weight, icy chill, and absence of sunlight make this place seem utterly lifeless, a realm where only the hardiest can endure. Yet, this desolate world holds secrets that challenge everything we thought we knew, strange life forms adapted to the impossible. The Mariana Trench is not just a geological curiosity, it's a frontier of discovery, a place where science meets the unknown. What we find here will redefine our understanding of life on Earth, and perhaps even the possibilities for life elsewhere, in the universe. The journey into the abyss has only just begun, and the mysteries waiting in the eternal night are far from over. For generations, scientists believed the deep ocean trenches were lifeless voids, places so remote and inhospitable that the very idea of life seemed impossible. Without sunlight, photosynthesis was impossible, and only a slow rain of marine snow, tiny fragments of organic matter drifting down from above, could provide any nourishment to whatever might exist below. The relentless cold and crushing pressure suggested a world of scarcity and near stillness, where energy was rare and movement was minimal. Early explorations seemed to confirm this bleak vision. Samples were often empty, and the few creatures found appeared sluggish, adapted to a slow-motion existence. The deep sea was seen as a static, unchanging desert, a place where the story of life had reached its quiet end, far from the sunlit world above. The environment was thought to be stable, always cold, always dark, always high pressure, with little to disturb its eternal silence. No seasons, no storms, no surprises. It was a world frozen in time, untouched by change. This tidy, orderly picture shaped deep-sea science for over a century, guiding research and fueling the imagination of generations of oceanographers. But nature, as it so often does, had a surprise in store, one that would challenge everything we thought we knew. A discovery was about to force us to redraw our maps of life and rethink the very limits of survival in the most extreme environments on Earth. The abyss, it turned out, was not as still or as empty as we once believed. Life was waiting, hidden in the darkness. The deep was about to reveal its hidden dynamism, and with it, a new chapter in the story of our planet. Everything changed in an instant, as if the ocean itself had decided to reveal a secret it had kept for millennia. The turning point came with the arrival of a new generation of sensitive instruments, technology capable of detecting even the faintest changes in the deep. Robotic vehicles, bristling with precise temperature sensors and advanced data loggers, descended into the trench, venturing deeper than ever before. For days, the water was as expected. Uniformly cold, just above freezing, a silent world untouched by sunlight or warmth. Then, without warning, the sensors registered a dramatic spike, a burst of warmth in the freezing deep. Scientists were stunned, unable to believe what they were seeing. In a world thought to be unchanging, this sudden heat seemed impossible, defying everything they thought they knew. At first they suspected equipment failure or a glitch in the sensors, but repeated tests and recalibrations confirmed the phenomenon was real. Again and again, brief pockets of warmth appeared and vanished, each one more mysterious than the last. Something hidden in the trench was generating these bursts of heat, as if the deep earth itself was breathing. This discovery shattered decades of scientific belief, forcing researchers to question everything they thought they understood about the deep ocean. The deep was not dormant. It was dynamic, alive with energy, and perhaps even more complex than the world above. But what could possibly create such heat, so far from the sun and the familiar warmth of volcanic activity? There were no volcanoes here, no obvious source for this energy. The geological setting seemed all wrong, defying the established maps and models of the ocean floor. The mystery only deepened, and so began a new search for answers, one that would push the boundaries of science and human curiosity. The source of this impossible heat would soon lead to one of the most exciting and transformative discoveries on our planet. The hidden fires of the deep Earth were calling, waiting to be understood. The answer lies in hydrothermal vents, cracks in the seafloor where seawater meets the Earth's inner heat. Tectonic plates shift and pull apart, allowing water to seep deep into the crust. There, it heats up near magma, becoming superheated and mineral-rich. This water erupts back into the ocean, forming plumes of black smoke, clouds of minerals solidifying in the cold. These vents build towering chimneys, fragile and ever-changing. The hot fluid creates temporary pockets of warmth, explaining the heat bursts detected in the trench. Finding vents at such depths was a monumental discovery. Even in subduction zones, deep fissures can allow water to circulate and heat up. The Earth's inner fire breathes energy into the darkest corners of the ocean. Here, life finds a way, powered by the planet itself. Around hydrothermal vents, a unique chemistry unfolds, a deep-sea alchemy that creates life without sunlight. The vent water is a hot, mineral-rich soup, especially high in hydrogen sulfide. To us it's toxic, but to vent life, it's the elixir of survival. Chemosynthetic bacteria use this chemical energy to create food, forming the base of the ecosystem. These bacteria are the plants of the deep, thriving in shimmering mats on the rocks. The immense pressure here prevents water from boiling even at 400 degrees CC, creating supercritical fluids that dissolve minerals efficiently. This potent chemical brew fuels the entire ecosystem. The energy comes from below, not above, a separate self-contained system. Some scientists believe life on Earth may have begun in places just like this. Hydrothermal vents are not just oddities, they're engines of creation in the most extreme environments. They transform the raw materials of our planet into vibrant life. Where there is energy, life flourishes, even in the abyss. Around the vents, vibrant oases teem with giant tube worms, yeti crabs, and swarms of blind shrimp. Tube worms, with no mouth or gut, rely on symbiotic bacteria inside their bodies to turn vent chemicals into food. Yeti crabs cultivate bacteria on their claws, harvesting their own food supply. Blind shrimp use thermal sensors to find the perfect mix of hot and cold water. This ecosystem is built on chemosynthesis, not sunlight. Creatures here withstand crushing pressure, toxic chemicals, and extreme temperatures. The food web is complex. Bacteria feed grazers, which feed predators. These deep-sea gardens have changed our view of life's possibilities. Life can thrive without the sun, powered by the Earth itself. Each new species discovered reveals more about survival in the most unlikely places. The deep reminds us, life is endlessly adaptable. Studying deep-sea vents is more than curiosity, it's vital science. Vents reveal how heat and chemicals move from Earth's interior to the oceans, shaping global cycles. For biologists, these ecosystems are laboratories of evolution, showing how life adapts to extremes. Unique vent proteins and enzymes have already led to breakthroughs in medicine and technology. Most excitingly, vents have transformed the search for life beyond Earth. We now know life can exist without sunlight, powered by geothermal energy. This means moons like Europa or Enceladus, with subsurface oceans, could harbor life. The bizarre creatures of our deep sea are models for what alien life might look like. By studying them, we learn not just about Earth but about the cosmos. The Mariana Trench is now a gateway to understanding life everywhere. Despite their remoteness, deep-sea vents are threatened by human activity. The vents and surrounding seabed are rich in valuable metals, attracting interest in deep-sea mining. Mining would destroy vent habitats, killing unique species and smothering ecosystems with sediment. Many vent species are found nowhere else. Mining could cause extinctions before we even discover them. The loss of biodiversity would be immense and irreversible. We are racing to exploit the deep before we understand it. Scientists urge a moratorium on mining to allow time for study and protection. The fate of these mysterious gardens rests in our hands. We must choose between short-term gain and the preservation of irreplaceable life. The deep sea's secrets deserve our respect and caution. What we do now will echo for millennia. The discovery of impossible heat and vibrant life in the Mariana Trench is a humbling reminder. Our planet is still full of secrets. The deep ocean is Earth's last great frontier. We know more about Mars than our own seafloor. Every expedition reveals new species, formations, and processes that challenge our understanding. The deep ocean is not distant or irrelevant. It drives weather, circulates nutrients, and regulates climate. What happens in the deep affects us all. Understanding this connection is more important than ever. The mysteries of the deep are essential to our survival. The journey of discovery continues, inviting us to remain curious and keep exploring. The ocean asks us to imagine what lies hidden in the dark. What other impossible things await in the crushing pressure and eternal night? The greatest discoveries on our planet may still be ahead. The deep sea's story is just beginning.